So I'm sure everyone remembers this. If you don't, this is a Modlet Smart stupid outlet. I did a review and teardown of a few months ago, or actually probably more like a year. So this, basically you can report power usage, and it has relays to turn on and off the outlets, and was about, I think, 70 or 80 bucks for 2 plugs. Basically, I had a Python. The problem with this was entirely the fact that the software it came with was violently terrible. And then to just add a, insult to injury, a few months ago it just spontaneously stopped talking to the little USB dongle shit. So like it literally, like I had a Python script that talked to it and basically got power consumption usage for it like every 15 seconds or so, which is the update rate of it. And then just spontaneously one day, like it was running, and then it just stopped giving results, and I was completely unable to convince the outlet to resynchronize using their bizarre, it's a 802.15, I was completely unable to get it to resynchronize and reconnect and then actually start reporting values again, so it's just been sitting around doing nothing. So I was at Fry's today, and here's D-Link's newest little wank bullshit thing. They've had the smart plugs for quite a while. The ones they've had in the past were just a wirelessly controllable switch. This one interests me because it's a wirelessly controllable switch that has power consumption. You can see it's got wattages there. They don't really monitor energy use of connected devices. So this was $50. I probably can't really afford it right now, but I have poor impulse control. And I'm just kind of curious, and I like knowing how much power stuff is using. Unfortunately, the whole energy plug project has kind of been put on halt by the fact that it needs a networking layer, and I'm apparently not bad enough to write my own networking system in C, at least at this time. I should really revisit it. So this is mildly interesting for a couple of reasons, one of which is the fact that it seems to really want to use... they have their stupid bullshit apps, which I'm probably going to try and write a Python script to work around, because fuck that. But it uses Wi-Fi, which is kind of interesting. Oh, this is nice. So, written offer for GPL and LGPL source code. So, I would assume that means this is probably running full-on Linux, which is definitely of interest to me. I've been doing a lot of Linux shit. One of the things I want to do with this is possibly break the switch. I think I'll probably take it apart and hard solder across the relay, because I don't want some dillweed on the internet being able to turn off my my servers, which is what this is going to be running. I'm actually, I guess, like a lot of people like the whole smart home thing, and I actually just want power consumption monitoring. I have no interest whatsoever in being able to turn it on and off remotely. So I may jumper the relay in there out. But in any event, it looks like it's just got 2 screws. Let's pop the back off and have a look. The fact that they say it uses GPL and LGPL code makes me think, like, I mean, the Modlet uses an embedded microprocessor with like a proprietary wireless stack, but this, it kind of sounds like it uses a bit more complex of a system. They've done the usual put screws under the label because asshole. So if I'm lucky, there may, I don't know how this works. We'll see what the processor looks like. If it's running Linux, I can either, there's probably a debug serial port in there somewhere that'll get me a terminal. Or, if I remember correctly, the previous version of these had so many security holes. I might just throw some, whack it with Metasploit and see what falls out. Probably all sorts of fun stuff, because I bet the kernel version in here is like 5 years old. Like just about everything embedded, because the Internet of Things is a terrible idea. So there's our stuff. So it's a 2-board sandwich. We obviously have energy usage and consumption stuff on the bottom, and then it looks like there's just a single board computer with very few pins. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got a total of 9 pins connecting to the outside world. Down here is our wireless antenna. It's kind of cute. So it's just an FR4, like bizarre patterns of copper on fiberglass because RF is weird affair. It certainly looks like FR4. Single antenna. We've got our little clicky button there. There's the point. There's where the antenna couples in. Looks like there's provisions for an RF can on this side. It's kind of interesting. We've got a bunch of like PCB pads there on that P2 connection that have flux grunge. There's a lot of flux grunge in general. So on the whole, it's very nicely built. I mean, you can see here's our LED, or oh no, I don't know. Yeah, okay. So there's actually 2 LEDs. There's one here, and there's one here. So this is quite nice. Actually, if you look here, you'll see these are those are machine-threaded screws. They are only going into plastic, which is kind of disappointing. So here's the wireless module. So there's the power supply, however it works. There's your current shunt relay, 16 amps, 250 volts DC, switched by 12 volts DC. It looks like this is so the power supply input comes here and then routes around. I see a big complex chip on the bottom side of this, so I suspect the energy monitoring is actually on this board as well. This is a little bit too small. Beverage. So from the fact that the relay is 12 volts, I'd assume this switcher probably outputs 12 volts, and there's a couple little inductors down there that might then be used to go the rest of the way. Kind of interestingly enough, a lot of this, like, you know, given that I designed a system that's very similar in intent to this, like you've got your big flameproof resistor on the input, then you have, looks like a, you know, so this also doubles as a fuse. That may actually, I think that actually is a fuse. Yeah, that's a fuse. It's not a flameproof resistor. Cap across, common mode inductor, bridge rectifier, switch mode stuff. It's probably a power transistor. So I think, okay, so that's all that's holding that down. Now it's just held on by the screws that hold the plug in. One thing I will say for this is that the plug assembly is, I have a lot of confidence in that being nice and strong over a long period of time. Now, if only they'd sell us these, that would be so wonderful. Ugh. So, yeah. So here's the back side of the board, and we have nice isolation milling, and then there is a chip with a QR code on it, interestingly enough. Let's pop the cover and see what's there. So this is a PL8331, and I don't recognize the semiconductor manufacturer. So here we are. So this chip is made by, I don't know who that is, but it's a PL8331 G1338C1 GCAS54000. And it's got a sticker on it which makes me kind of think microprocessor. And then there's also a tuning fork style crystal over here too, which is kind of interesting. So whatever that is, it apparently has an RTC of some sort in it. Got some diodes. That is one of the... Okay, so that's interesting. So these two pins here and these two pins here are both the relay. Oh, that's interesting. NTC2. So one thing they did I did see on the documentation for this is it has temperature sensing. So it looks like it's got at least two NTC thermistors on it, and there's one of them. You can see here this is one of the header interconnects that goes to the other board. And then there's also that other header there, which just appears to be empty and is a little fluxy. There is a little 4-pin header of unknown purpose, and a 2-pin header of unknown purpose as well. You can see a bunch of those little inductors I was talking about. So down here is our, so there's the bridge rectifier, and then that FSTA U12 down there I would assume is the primary switch mode controller for this transformer. There's the relay, just a single pole, single throw, normally open, apparently. And then you can see here's your current shunt. Actually, look at that, yeah. So if you see here, so if you see there, you see these two, those two traces, which kind of run out as a pair and then split out. That's the Kelvin connections for the current sensing, which appear to run under this diode to these two resistors, these two capacitors. Yeah, it looks like a pretty common input network for that sort of stuff. And then it looks like whatever this chip is, it has low noise PGAs. Over here we can see we have, these are 750 kilo ohm resistors, and we have 4 of them in series. And then it looks like they terminated into a 1K resistor to ground. That looks pretty much like your common 120 volt to, you know, say 1 volt or so mains divider network, and where you, again, because these resistors may only be able to withstand, you know, 75 volts each, you use a bunch of them in series to kind of spread your voltage drop across. Some not too splendid soldering on all these big heavy things, which I can't really blame them for, because that's a lot of, I mean, you need a lot of heat to solder that. Kind of some oddball, interesting ceramics. And the diode, here's that crystal. It looks like there's 2 big ceramics here, but I think that's right on the underside of apparently a number of little DC to DCs of some sort. In fact, this may be another DC to DC converter. Interestingly enough, that's also, this is a U part. Can't quite make out what it says on it, but it's one of the more upside down. That is a N19-N3 FSF34K. My assumption for something that's got all that labeling on it and is just in a 3-pin package is voltage reference or shunt regulator or some sort. Could be just a series regulator, I guess. Yeah. So, anyways, that's the main board. So here's the RF board. So we can see there, that's money's on it. That's a big ass flash, 25L640. Yep, that looks like a big SPI flash. I bet that's the boot flash for this thing. There's one of our little clicky buttons, and then up here we have a crystal. That is a it's either 25 megahertz or 20 megahertz. It's just, can't really make it out. I'm not sure. I think it's 25. It could be 25.68. Anyways, we've got a lot of little passives. There's another LED there. It's a dual color LED there and a single one there. You can see a lot of these serpentine traces, which are going to be trace length matching, which means they've got some high-speed stuff going on somewhere. There's that interesting pin header there that I would have put some money on it as some sort of logic of some sort. Interesting, an unpopulated footprint for an LED. So over on this side we just have, oh yeah, and then you can see over here is where the RF terminates, and if we flip over, it looks like that's a UFL, presumably for testing of some sort. So fortunately this is not a permanently mounted incidentally, there's another little button over here. Let's see if I can get you to pop off. Yeah, there it goes. Alright, so we have an Theros AR1311 -AL1A and a big, I bet that's like SD-RAM or DD-RAM. It's probably DDR. It's going to be DDR. So that is a M1D5121632A. And then a lot of passives, and that's it. And you can see over here, all those things with blue labels, I'm 99% certain are inductors. So this is going to be probably a complex matching network for the Wi-Fi. You see over here we have this little 6-pin device there. That could be a transmit-receive switch, it could be an amplifier. It looks, I mean, my assumption about transmit-receive is it looks like it's right on the path, and it's actually also marked SW3. So my assumption would be, if you look down there, we kind of have what looks to be an RF path running over here and an RF path running up there. Actually that's interesting, there's a Q right there. That little black thing is actually a transistor. So that's probably the transmit, and I bet that's just like a power amplifier. So obviously whatever this is, it's got to have a core, a microprocessor core of some sort. That's either power switching or just, I'm not sure, power switching or maybe a regulator that's labeled Q. There's another one. Excuse me, there's some big ceramics in here. And then there's whatever that is, which actually looks like a big ferrite core. That looks like a little chip inductor to me. But there's not that much in here. I mean, it's... Excuse me, I have the hiccups now. It's quite sparse. So it's mostly back together. It's not screwed together, but it is reassembled. So let's have a poke around. Okay, so let's first have a minor, kind of segue your discussion on the topic of safety. So this is not just plugged into an outlet strip. This outlet strip is plugged into my medical grade isolation transformer. So, usual, if you're going to be poking around on mains connected stuff, and it's critical to remember that, all the electronics in here are connected to one of the mains lines. If you're lucky, very much if you're lucky, it's connected to the neutral, so it's going to be fairly safe. If you're not lucky, yeah. So what I've got going on is I have a proper isolation transformer that the whole thing's now floating on. So the output, basically, I can be therefore either the hot or the neutral can be grounded without causing any significant repercussions. But again, unless you have that sort of, something like that, you have a proper isolation transformer. Doing stuff like this can be rather unsafe. So anyways, so red LED, just it seems to be sitting there. So if I push the, does not appear to have booted yet. So just to be clear, that lights up there. So obviously pushing this button caused the relay to either pull in or pull out. I'm not sure which. That does not actually appear to be an LED thing, it just appears to be a decal. Okay, so it appears to now be booted, and that's now flashing orange rather than red. That's interesting. So, here's I can no longer turn it off. Okay, well anyways, so things. So now let's start having a poke. So, first assumptions we can make here are that this antenna point right here is very likely going to be ground, because the circumstances in which the antenna is not grounded are going to be very unusual. The other thing that's worth of note is that the antenna is connected to this great big plane, which connects over here. It appears to connect to that pin right there. So now if we go over to this 4-pin connector, that's a diode drop. That's open. That's a larger diode drop. And that's a diode drop as well. So it doesn't appear any of these pins, or those pins at least. So that's actually grounded. So you have this other little 4-pin thing here. So these are all, that one's high impedance. That's 2 diode drops. 2 diode drops. And 2 diode drops. Should really, so it doesn't help much, does it? So I'm just obviously you can see I'm just, you know, poking onto the ground somewhere. Connected. So that is 1.9 volts. So over here, 1.6, 0.6. Oh, interesting. So it appears that pin is in fact grounded, and I was just making a bad connection earlier. Yeah. So that's our ground. So that's nice. We now have a ground in that connector. That one's 1 volt, 1.6 volts. So other stuff I can do is, like, we have a big ceramic here, and just by poking around, we know that side of the ceramic is ground, and that side of the ceramic is presumably one of the voltage rails. So now what we do is, actually what I think I'll do is I'll actually put something I can clip onto here. So this will just be my ground connection. So now if I just go over here, yeah, 0 volts. So power it up, power it up. So now I'm on volts DC. So let's just look at this terminal here. So that is 3.3 volts roughly. So it looks like we're running a predominantly 3.3 volt based system. So my assumption here would be that pin 1 of this, I bet it's a power rail. Yep. So that's at 2.6, and that's at 1.4. So over here, 0, 0, 0, 0. So it looks like most of the stuff of interest is right here. Actually, there's an interesting check we could do, which is just go back to beeper mode, go to this pin here, and then go to here. Yeah. So obviously, if this capacitor is connected to that pin, that means that's going to have to be a power rail. So actually, while we're at it, why don't we, let's look at these pins. This, I believe, is ground. That appears to also be nothing, or a signal. Nothing there. Nothing there. One of these has to be power. There's 2.6, there's 3.1, and there's 3.2. So it looks like that's the power connection. And then actually, it looks like both of these pins over here are actually ground, as is, I think, this pin there. That should be ground, yeah. Not too sure what those are. One thing of interest I see here is that that's flickering. So now let's start with the scope. Ooh, interesting. Okay, so what do we have here? Yep, that's serial data. So now let's turn on one of my decoders, RS-232. Once that is on, TX is going to be channel 1. Baud is, okay, looks like it's 115200. Polarity normal. So that, well, what's our bit time? I'm just not sure. It looks like it's kind of assuming that another byte is coming in there. So I think it's trying to do more involved, like it's assuming something's coming on from before. I'm not sure. Yeah, anyways, so it appears that's definitely a serial port. So let me tack on some connections. So this is one of the reasons I like PC-based logic analyzers. Here is 1 billion samples. So we can kind of zoom in and take a look here. So that sure looks like serial to me. So let's turn on some analyzers. This is going to be on channel 1. We'll autobot it. That is not autobotted correctly. 1152. Yep! Haha! /r/n/r/n. U-boot 1.1.4. So I'm hooked up with a very minimal, just an FTDI breakout board, and I definitely am seeing serial traffic, so let's restart it, and there is it booting. So please press enter to activate this console. BusyBox 1.01 LS. Oops. I think I can manage to avoid typing a... Yeah. Cannot type with one hand. Error. So one of the things you see going on here is the meter stuff, which I assume is related to the scroll down, which I assume, I'm fairly confident is related to the power stuff. But unfortunately it seems to steal, like it's now gone unresponsive. It just periodically does that. So I'm assuming you have like a short window for dealing with the BusyBox stuff before it boots. I just pushed the button, which caused it to emit some messages. Pushed again. Did it again. Just depowered it. Start it back up. There's the boot sequence again. So we have LAN manager, switch notifier, light, HTTPD, and I'm gone. Prolific. I didn't see any prolific devices on there. Yeah, so it appears there's a short period of time when I have a console. I would assume that's what the timer 60 is. Let's see if I can't kill that before it does anything. So this is pretty funny. I'm just poking. It turns out they have just it's a SOAP interface technically. I'm poking around at the interface, but it turns out somebody forgot to update the identification string. So this is the DSP W215 which is the switch, but somebody forgot to change it. It still thinks it's a wireless N150 travel router. So I did some research. There was a in a previous version there was a kind of a pretty spectacular Stack Overflow vulnerability that lets you just do whatever the hell you wanted with it with no auth. But that appears to be version 1, and as you can see here, this is version 1B23. So it appears they've patched that. I just actually tried to hit it with the exploit and didn't do anything. So now I'm kind of stuck trying to figure out how the HNAP, which is a Home Network Automation Protocol. Basically, I don't really care much. I just want to get the... I don't ever want to be able to turn it on and off. In fact, I'm going to physically disable the ability to do so. I just want to know what the power is and what the temperature is. So I'm going to poke around some more. So success, kind of. So I did a whole bunch more poking around in the basically the file system. I actually just restarted it, so it's on a clean install. And it turns out there's a file in there. I had to rename them. There's a file in there called checklist.htm, which if you look in the actual file contents, actually just does a post request to mycgi.cgi with the value math.random or with the parameter math.random just on the client side, and the actual input types just a request create checklist. And it turns out that if you poke that even on a new plug, you get just an empty, basically a very plain just a text file effectively. But one of the things you get in there is meter watt, and it's slightly interestingly, it's more precise than the number in the iPhone app, I believe. Because this one, it was only 240. Well, so here's the iShit app. Let's see, it's incredibly slow, which is one of the things I noticed. Also, I'm currently bouncing through a proxy. So you can actually go over here and you can see, let's see, I don't think it's on the right place. So here are all the HNAP requests. So this is the, you can see, actually one of the things that's interesting here is that because I shorted out the relay, technically the user interface is telling me it's off, but the myCGI interface is still reporting the correct wattage. But if I turn on the relay, it has to think for a long time, and then this only tells me it's drawing 12 watts, whereas through the web interface it tells me 12.3, and this is just a fluorescent light. So that's about what I'd expect. So I'm pretty happy about that. So if you look, that's not the terminal window I want. Here's the COM window. So this is just, so the circuit's over here on my bench. You can see it there, just with the light on and a bunch of probes hanging off it. It's sitting on my big isolation transformer down there, which is how I have it connected, because otherwise shit would go south in a hurry. You'd probably, you know, unless I was definitely sure I was on neutral. But you see here, this is just a number. I don't actually know what this is exactly, and it's just periodically, whoops. It just periodically should update, I believe. Yeah, see, there you go. And I bet if I now refresh this, it'll say, oops. Well, assuming I don't. Yeah, see, now it's 12.0. So it looks like this value here, I would assume, is the current wattage. I don't have any idea what this is. 2.15, I think, is the firmware version. And the 8.0 versus 8.2, I don't know what that is. There doesn't seem to be any provision for reading back. Oh, I know what that is. That's the temperature sensor. There does not seem to be any provision I found for reading back the voltage, the line voltage. And also this web interface does not seem to include the temperature, which is a little irritating. Also, D-Link's fucking bullshit. They want me to join their cloud so they can then fuck up my shit when their server goes south without them paying attention. But, yeah, in any event, this is more or less everything I need. I can just, I mean, I'll fake the post request to this myself rather than having to deal with this. It's kind of funny that the MyCGI seems to really want, it requires a random number. Or, I don't know, maybe that's how it I don't know what the hell the random number is for. But I mean, if you look in the file that generates the request, so other fun stuff is, like, inside a lot of these files is still a lot of old crap. Like you can see here, this is still a D-Link Systems wireless repeater. There's other funny stuff like it still has a login page for no particularly coherent reason that actually seems to be reporting the wrong firmware, which just makes it even funnier. Oh wait, no, firmware version is 1.10. So, and hardware version here is A1. So this seems to be correct. And the password, the login password is just a little card with the pin code. So you log in and then it takes you to this page, which doesn't tell you anything. It's a different interface. Actually, let's see, how is... Anyways, yeah, oh wait, plug bins. Yeah, so I mean, in here there's a number of different things. There's two primary applications. There's, wait, no, maybe there isn't. I'm only seeing the MyCGI app, but, I don't remember, what was the mapping? Yeah, there's some interesting file system stuff. Like, I think this is just reading a file, and there's an autonomous process that updates everything. But yeah, so in any event, I should now have a little library that talks to this and queries the plug state in regular intervals. Cool. Yeah, so I get 11.9 watts. So great, I'm going to go put this back together and stick it in my server. So I'm not sure if I had pictures of this earlier. So here's the plug. And you can see here are my the two test leads I've got. So this is so pin 3 is TX and pin 4 is RX. Pin 2 is ground. So I'm just using this as my ground just because it was more convenient. And then pin 1 is 3.3 volts. And it's 3.3 volts TTL serial. Okay, so as you can see, I don't know if you can make it out, but we now have data streaming, and if we go into my Emon CMS instance, we have data, and I'm not sure how much you can make out, but it's updating in real time. Doesn't change that often, but you can see the gauge changing, and the graph doesn't update in real time, unfortunately. But I'm slightly oversampling it. You can see here I have a number of data points at each value, which is fine. But yeah, so I just took the code is now I threw it up on GitHub. Let's see, just it's literally like one file. There's not much to it. But if anyone's interested, yeah. So now you have a little script that you can run. This is, in this situation, it's actually running on a Raspberry Pi. And then I just leave it running inside Screen. So actually on here I have the Emon CMS stuff, and I also have a weather thing, which is what's responsible for this graph up here, which is like barometric pressure and temperature and other stuff. See, it's pretty warm here. It's currently 35 degrees in my closet. It's about 28 degrees where I am right now. It's pretty roasting. Not fun, but yeah. So cool. Excuse me. Yeah, so cool. Yeah, so that's if anyone else wants to buy one of these, they now provide usable data. You can now get the data into something else. Oops. Just kind of bobbling up and down.